So welcome. I'm glad you guys are here. And I first started working with Go last December. And I currently teach Go at California State University, Fresno. And we do web programming class, and then we do an advanced web programming class with Go. And I'm also teaching it at Fresno City College. So I'm from Fresno, and like I said, I just started learning Go last December, so I'm 9 months new to the language, and there's definitely things I don't know about it, but there's a lot that I've figured out. And I want to share with you, one of the most important takeaways I want to give to you today is resources, the pathway. So I can't teach you everything in 2 hours, or even one, if you're only going to be here for 1 hour. This hour is going to build on the next hour. But I think you guys are in a really great place, because everything I've seen about this language, every time I kind of like, as I learn more and more, I'm like, oh, I'm really glad I chose this language. And so I just want to present to you a little bit about why Go. So we'll talk a little bit about why Go, and I'll give you some of my thoughts on that. And then we're going to look at a lot of code, and I was up last night just sort of trying to put together the clearest pathway that I could for doing web programming with Go. And what that looks like. And so I have a GitHub repo, and that's right here. Goes to 11. Not sure if there's anybody who knows that reference. I was up really late, so I'll be having those moments where I forget my name. I'm like, what was my name? It's from Spinal Tap. This is Spinal Tap, right? Kind of a funny scene. You could YouTube it. But if you go into my GitHub and then go to Golang Training, and these are all the files that we use at Fresno State, that we're using this semester at Fresno State for web programming. So it's a really nice, clear pathway. And if you scroll all the way to the bottom, I added 99 SVCC. And so that will give you, we're going to look at like, how do we build web pages and make dynamic web apps with Golang. And something that's a little bit surprising to people when they first come to the language, or maybe they don't know it, if they've been working with the traditional old school way of building web apps, where your URLs point to a file on your server. So index HTML corresponds to a URL, right? All of this is RESTful. And then also you don't have a server. You don't have to use Apache or IIS or anything like that, right? Your server, you build your server right in Go, and it serves your files, and that's all compiled to binary, and it's lightning fast. So that's something that also, that's just like one of the first pieces of information you need to know. Like back in the old days, you'd learn PHP, and then who knows what the hell Apache's doing, But when you start learning Go, you got to know the whole web deal, like how everything's working, HTTP verbs and all that. And you're building your web app, and you're building the server. And it's not that complicated, but it takes a little bit of time to sort of become accustomed to it. So why Go? So for me, one of the first things that really sort of caught my interest about Go was that it is built by geniuses. And so Ken Thompson, Rob Pike, and Robert Gressimer are like, some luminaries in computer science. And these guys have created some of the most seminal, influential things that we use in computer science. The C programming language, Unix, UTF-8, these guys were all on board with that. They now work at Google, right? And they were working at Google, and Google, which, is an amazing tech company, was hitting a wall with all the current programming languages. And they said, we need a new language, right? And the wall that they were hitting with that was that, or some of the things that current languages can do that they wanted to do is they wanted to be able to do concurrency really well and really easily. And then they also wanted to be able to take advantage of multiple cores. Traditional languages are written, and they're written really only for one core. That's all we had in the past, right? So Java, C, C#, C++. If you want to do things with multiple cores, parallelism, that becomes a little bit more challenging in those languages. They wanted to have a language where that was baked into the language was built to use that and take advantage of it. And so just the fact that, Google, amazing tech company, these guys, geniuses, created some of the most influential things in computer science, right? They say, both Google and these guys say, we need a new language, right? And then they go and they create this language, and, and this is the language that they say, hey, this is what we need to use, and now Google's using that. It's like, okay, I want to take note of that. Like comparing that to like other choices that are out there. Because, you know, it's like, hey, so what I want to do for server-side language, you could look at Python, you could look at Node.js, you could look at Ruby, you could go totally old school and do PHP, ASP, or you could go even further back and do like Cold Fusion. And, you know, or you could maybe like take a look at Go and what's Go do. So my ranking of server-side languages would be number 1, Go, number 2, Node, number 3, Python, number 4, Ruby. And Node is going to be twice as slow as Go, and it's going to have a lot of performance issues. But with, and then Python, right? Like it's created by some guy, Guido, right? Who like decided, look, the version I created, version 2, was so not right. I'm going to break backwards compatibility and create version 3. And so he creates version 3, and then nobody follows him to version 3, and everybody's staying with version 2. And to me, that's a really big red flag. It's like, wait a minute, right? Nobody is going to version 3. So anyhow, those are some of the things I was thinking about when I was like, okay, which language do we want to start teaching? And these are some of the main reasons I chose Go. So it's performant. It can easily take advantage of multiple cores. So, you know, like you could run Go and then look at your activity monitor and you can see, wow, I'm maxing out my hardware. My hardware is running full RPMs, pedal to the metal. It does concurrency really well. It's compiled, right? And it's also a statically typed language, so you get all that safety and prevent all of those other errors. And it works really well in network environments. It's a low-level systems-level language with standard library packages that let you do some really high-level things, right? So it has a really clean syntax. It writes really quick, really light, really easy. It reads really well. You're going to see some of that today. And you know, yeah, so for me, it's a really easy language to write in, easy language to read once you sort of get used to the syntax, right? It's the first thing you got to learn about any language is the syntax. It's portable, so it will compile onto many different operating systems. And it's also backed by Google, right? Okay, cool. And it's also open source. So you can learn Go and you can start, you know, contributing to the standard library, and if your code's good, they'll bring it into the standard library. You know, who's going to say no to free work? So this is a subjective graph, and it's not my graph. It's put together by a guy, you know, at Tokyo Gopher conference in Tokyo. And this is kind of like how he categorized all the languages. I kind of like that, right? Fast and fun for humans, fast and efficient for computers. You can kind of see the layout. And that's sort of how he saw and I see Go fall into the ecosystem. And then, you know, beautiful straight code and efficient concurrency. Right? And so that's again a subjective thing, but that, you know, that goes a long ways to sort of describing what people are shooting for, what Google was shooting for when they created this language. So Google, when they released the language in 2009, you know, they kind of like said, hey, here's an unfinished language we're working on. Thought you might like to check it out. In 2013, they released okay, this is version 1. You are coming to Go at a really good time, because just a month ago they released 1.5, version 1.5. It's like, I think, the 5th or 6th release. And the language is now finished, the standard library is finished, right? So they're saying, hey, it's all done. And so, you know, it's time to start using it. But I like what they said when they released it, right? Obviously, they're going to think about this. Here at Google, we believe programming should be fast, productive, and most importantly, fun. That's why we're excited to open source an experimental new language called Go. And again, this was 2009, so this was 6 years ago, before it was even version 1. Go combines the development speed of working in a dynamic language like Python with the performance and safety of a compiled language like C or C++. Typical builds feel instantaneous. Even large binaries compile in just a few seconds. And the compiled code runs close to the speed of C, or close to the speed of light. Go lets you move fast. I'll sometimes use like totally off-the-wall euphemisms, or what are the hyperbole. Go is a great language for systems programming and support for multiprocessing, a fresh and lightweight take on object-oriented design, plus some cool features like true closures and reflection. Want to write a server with thousands of communicating threads, want to spend less time reading blogs while waiting for builds. Feel like whipping up a prototype for your latest idea, Go is the way to go. Sorry, gotta breathe. Companies using Go. So this is also a really important thing. Like, I don't want to learn a language and then it's just in like, and I can't do anything with it, right? And I've been going to, like, one of my mentors in Go is a guy, William Kennedy. I'm going to talk a little bit about him and his resources, and if you sign up afterwards, I'll even give you a free copy digitally of his book, which is going to be released in December 2015, which is the best book I've read on Go, and he's one of the best, he's one of the biggest community builders right now. He runs Ardent Studios and Ardent Labs, and he does these amazing trainings, and I forget why I was telling you all that. But I remember, I was at his training not too, like about a month ago, one of his trainings, and there was a young woman, who's had a couple of years of development experience, and she's in between jobs, so she came to the training, and then she came back to another training, and then she'd been to 2 3-day trainings, and then she got a job as a Go developer in San Francisco. It's like, I had like 6 days of training. They're like, can you solve these code challenges? And she like totally did those code challenges, like, you're hired, right? And so here are the companies that are using Go. Here we go, you ready? Whoa, whoa. So, there's actually a lot going on, and a lot of really big players are like, oh yeah, this is what we need because we're hitting the wall with all these other languages, and this one can do it. Whoa. New York Times is hugely invested in Go. Like, they're all Go. All these companies have live running Go code. Go is huge in China. That was weird. I filled it up with the bubbly water at the side of the fountain. It's a party. So a lot of people are like, yeah, Datadog, awesome. A guy who works at one of the developers at Datadog is also one of my code mentors. You had a question? I don't know. But yes, I do know. Thank you. Bill Kennedy, I'm not sure if I could say that. So something that's really large and delivers a lot of television to your house, and they have set-top boxes, all that's going to be in 2016 Go. I don't know what these people do, but I like their homepage. Flying Cat, I think I need to go check them out. This is going to end soon. I stopped at a certain point. All right, so one of the other things which really stood out to me was, like, some of the lead contributors to building Node.js said, to hell with Node, look at this. And they left. TJ Hollowaychuk, gone, right? He's one of the primary contributors to Node.js. He said, I'm leaving Node for Go, right? This is one of the guys that built Node. He said, to hell with Node, I want to use Go. And you could read, these articles. You'll have access to all these resources. So what other languages used for all these? Web apps, scripts, systems admin, image processing, load balancers, servers, crypto, hardware, Android, and iOS apps. One language for both Android and iOS apps. That's like the new thing they're trying to get with Go. It's still very beta, cutting edge, but pretty soon, a year, 2 years from now, you'll be able to create both Android and iOS apps using Go. And quite frankly, I'm excited about that. I've had enough PSVM. Initially, our Go-based system ran on 20 servers, with 20 million real-time connections in total. What? 20 million real-time connections? The system sent 2 million messages a day. That system now runs on 400 servers, supporting 200 million plus real-time connections, and now sends over 10 billion messages daily, right? Whoa. That's a company in China. So you can read this. That was like at the Shanghai Go conference. Somebody does a quote from somebody there. So one of the phrases for Go, like, if we could boil Go down to something, it's like do less, enable more. And that's kind of one of the philosophies that the Go community has about the entire language, like do less, enable more. As a developer, do less, enable more, right? Let's get more done. And then also, as we build this language, as the language is being built, we're building it so that, we're enabling people to do things. So that's from Russ Cox, who's the tech lead for the Go project, Go team at Google. So here's a review. Golang is awesome. And people refer to it as Golang because Go is a really hard thing to search for on Google. Holy crap, a lot of great companies are already using Golang. You should have already learned Golang a year ago, but at least you're starting now. And then this is Caleb Doxey, who's one of the engineers at Datadog and one of my 2 primary mentors in this language. And this is he has a book, which you can find at that URL. He says, Go is procedural, imperative, modular, object-oriented, statically typed, garbage collected, compiled programming language with syntax broadly similar to the C family languages, and CSV-inspired concurrency features. We will examine each of those descriptions in greater detail, but before we do, let's write our first Go program. Go is a procedural programming language because procedures, functions are stitched together to form a program. It's an imperative programming language because functions are built out of statements, which are generally phrased as imperative commands. So, just some of the buzzwords when talking about all this, but it also gives you an idea of what we're looking at. So I feel like when I got involved with web programming in 1998, this is kind of what it was like, right? And this is the path any industry takes. You know, things start out at the most rudimentary, cool, we got an engine, it drives a car, it's running, how awesome, right? And then, you know, more people get involved in the industry, and then people go to school and study it for 6 years and get out and start contributing to the industry. And then after, like, the industry's been around for a while, which in automobiles, that took like 80 years, but in technology, there's like dog years. You know, 1 human year is equal to 7 dog years. I think there's tech years, and like 1 human year is like equal to like 24 tech years or something, right? Or 1 tech year is, whatever, right? But anyhow, so this is what web programming was like when I started, and this is what I feel like it's like now, you know? And so, you know, it takes a little bit more to sort of like, okay, let me make this thing work. And Go was invented by geniuses, right? And unless you speak genius, Go can be harderish to learn from the docs. And so, you know, this is kind of what I felt like when I first started learning Go, right? It was like, man, this is a black diamond course, and you're just going, you know, full speed right over an edge. Like, there's no shallow end. And but fortunately, like back when I started learning, there was no real video trainings online. This was only 9 months ago. Like Pluralsight didn't have any video trainings. Now they have like 7, right? A whole bunch came out in May and June. And Udemy didn't have any video trainings. Currently, I'm contracted with Udemy to, you know, provide them with video training. Lynda.com doesn't have any video trainings. Currently, I'm contracted with Lynda.com, and by December, they'll have a training. You know, it's good when you have good resources and a good pathway. So that's kind of like one of the big shifts that's occurred in the last 9 months is now there's a good pathway. And I'm going to give you those resources, and I'm going to give you the good pathway. And so here are the resources, right, to help you learn it. And you're going to get access to all this, and this is how you're going to get access to it. So just write that down. Or take a picture of it, either way. While you're doing that, I'll provide a little anecdote, but I kind of see coding as a monastic devotion, right? Where it's like every day, man, it's kind of like I gotta do my chants and my mantras, you know, go and do my time at the altar or whatever. It's kind of a cool way for me to think about coding. All right, so if you click on that link or go to that link, you'll be taken to the syllabus for my advanced web programming class, in which case you're gonna have, whoa, you guys are already there. You'll have presentation slides, right? So you'll have all these slides, and this is sort of like the really slower way that things are laid out. So this is going to go a little quick today, but you can go through and sort of walk through it, you know, step 1, step 2, step 3, a little bit more clearly, slowly. And then you have all the presentation code, right, which is going to take you to that GitHub account I already showed you. And then I have a tremendous amount of videos. My colleague Dennis Mull and I helped Dennis with a grant that he was running, and we were able to put on this amazing summer web boot camp this summer, and we brought Caleb Doxey in for a month, 20 days of Golang intensive web programming training. And so we recorded all of those videos, and you can come in here and you can see day 17. The last 3 days was just hands-on coding with Caleb helping us, but you know, all the way starting out with day 1. And then there's other stuff in here, like we had, you know, Zena Rocha talk about web components and Polymer, and then we also had, you know, HTML, CSS with Ryan Bonhart. So we had some really great resources here for learning. You can teach yourself everything you need to know about web programming just with this thing right here. So there are all those videos, and slowly I'm indexing the videos, and so you can come in here and you can say, okay, cool, how do I do OS args with Golang? And oh, okay, it's this video, and I need to put those links in. Further in down here, I've started like linking it straight to the video. I thought, oh yeah, of course, that's a brilliant idea. I wish I thought of that when I first started indexing all these. So you have an index to all those videos, and then there's an outline that we followed at the Summer Web Bootcamp, and then the code, which is going to be a little bit rougher than what you find here. So this is the code we actually put together at the Summer Web Bootcamp. This is the code I'm putting together as I kind of refine it and go back through everything and take the time to write it a little bit more methodically. Some of the code in here is like partial code that doesn't run, but oh, there's that one piece, you know, that shows you something. And then Caleb's book, GolangBook.com, is really fantastic. And Go by Example is good, and you're going to see all that in a second. So you get to all that stuff just from that URL, right? There. All right, so here are the, yeah.
Sorry. You are confusing.
Okay.
When you say web apps, what do you mean?
So just like, you know, HTML, CSS, JavaScript, server-side programming, and, you know, this.
Okay, so could you explain, I mean, are you meaning that Go could do some of the front end or double the front end logic?
No, it can't do browser, server client-side programming. I mean, there's probably a way to figure that out, but you use JavaScript for client-side, but this is where Go is going to run. On the server, here are the clients, they make a request, and then there's a response. And
so it's very similar to Django from Python, right?
I don't know.
But
Yeah, okay, cool. So here are the resources, so Caleb's book. And then here's just another slide with links to all those resources, Bootcamp I showed you. This is Bill Kennedy's book, which is outstanding. So if you give me your email afterwards, I'll be able to email you a digital copy of this. And then Bill will probably follow up saying, hey, if you want to come to our training, here's 10% off or something like that. And this is his training, which is also a great resource if you want to learn about Go. And then there's the golangbridge.org has a forum, which is a really good place for community just to like ask questions or connect with people. It's like, hey, how do I do this thing, right? And then there's a Slack account, which is right here, so you can request access to that. And there's also Go by Example, which is real quick, like, oh my gosh, how do I do structs again? And then you come down here and find structs, and there's like all the little examples you need just real quickly. And then Pluralsight has a couple of trainings, which are really good. And then there's this one, how do I build a web app with Go, and building web apps with Go, which are okay, you know. And then, of course, the language spec is going to be one of your strong resources, but, you know, come to this after you've done some of the other stuff, you know, and also effective Go. And again, come to this after you've done some of the other stuff, but make sure you do come to it, read through it, unless you're, like, really, you know, skilled, and you could go straight to that. And then the Go blog is the official blog, and that's, you can just Google that, and they have really great articles that explain certain concepts in a little less technical terms. And then there's a Go newsletter, which will just keep you in the loop of everything. And then the golang.org website is the official website. And then there's also something else we're going to talk about in a minute. All right, so that's sort of like the introduction to Go. Let me just see a show of hands. How many people are like, after what I've heard, that seems like something I'm kind of interested in? Yeah, sweet. And how many people are like, we'll wait and see. Yeah, it might be like Dart or Google Glasses, you know. I mean, yeah, you know, some things they do, they totally succeed. Some things are like, well, that's cool. That was a good attempt. All right, so let's start looking at some stuff. So, you know, we're basically going to see, like, here I've got 40 slides. This hour, and the next hour is going to build on this hour. So we have 40 slides, and we have, you know, I don't know, an hour and a half left. That's like 90 minutes. That gives us about 2 minutes a slide, right? So just sort of like with a little bit of a break. So here would just be like a really basic, like, hey, right? I need to start creating a web page using some sort of a server-side language. And I'm going to start out with that just by declaring a variable, and it's going to be a string. And this is the shorthand syntax for declaring a variable in Go. And you know, Go has a couple of warts. And one of the warts, and probably the biggest wart, is that there's many different ways to declare a variable. And the two ways you should stick with when declaring a variable is to just use the shorthand notation when you want to initialize it to your own value, and then use var name string or whatever when you want to set it to the 0 value, which would be kind of like the default value, but you don't say default value in Go, you call it 0 value, because you would actually, your ints would be zeros, your floats would be zeros, your string would be empty quotes, and then all of your other more complex types would be nil. Not null, but nil. And so those are the two ways you should declare variables when you're just looking at stuff. Shorthand notation only works inside of a function. So if you want to use something outside of a function, then you'd have to use the var method. And so here I declare a variable to Top Cloud. Simple, clean, easy, right? Like that's one of the main things about Go is like, let's write a programming language that allows people to tell a story with code. We don't want to make things complex. If you're going to be clever, don't be clever. Like choose simplicity and clarity over cleverness and density, right? So write 20 more lines of code that is less clever but more readable. Like that's the proper way to do Go coding. And you want to make things readable. And so this is very readable, right? And a lot of their conventions are about like, let's make things readable and let's be really precise with the words that we talk about when describing the language. We don't do casting in Go, we do conversion. Because conversion really kind of describes what's going on a lot more. Casting, what is that? Is this a movie? Did I break an arm? But conversion, I'm converting from an int to a float, or I'm converting from a float to an int. Conversion is a more precise word to describe that process. So they change a little bit of the diction that's sometimes used in the language which we use to talk about this language. This language, like any culture, right, has a language to talk about the language. And so here I'm declaring a variable which is a string. And then I'm just going to print to standard out. Package allows you to do printing. And I'm printing this string, and then in the middle of the string, I'm putting that variable in there. And cool, so on the server side, I just had the server put together for me a little HTML page. And if I go into that, notice I got to move the mic so I could actually do a little bit more focused typing. And go into the first example, and go run main.go. You got a couple of ways you could build your binary and run your binary. You can do go build, which will just build it. You can do go install, which will build it and install it. And you can also just do go run. When you're starting out, go run is fine. When you get more into things, sometimes you're going to be like, oh, I got to do go build or go install just because higher level processing things are happening or something like that. I don't even quite understand that. It's just my code mentor say that, but I'm like, I guess I haven't hit that point because go run still totally works for me. Right? And so when you're getting started, there's certain steps you have to go through to get started, and those are all laid out really clearly in the PowerPoint slides, or these slides that you have access to. So getting started with Golang is going to show you how to set up your environment. What editor do I use is going to show you the two best editors that are out there, either WebStorm or Atom, and how to set them up and everything like that. So this is, and then here's Hello Go World. So I'm not going to go into like all the basics of your workspace or setting your environment variables and everything like that. But there's just a few key things that you have to do absolutely precisely to get this working right. And all of that translates to goodness down the road. So package name spacing, having things connected to repo counts, being able to, get other people's packages really easy with a simple go get command. Right, so it's kind of like npm package management, where I just say, hey, go get this other person's code. I want to use it, and then go get it off of repos. All right, so staying on track, right? So I'm going to just dump this to index.html. And sorry, the first time you run something, it takes a second for the whatever to wake up. And sorry, I did that wrong. Go build. Hold on. Tired brain. Yeah, here we go. All right. So just create a little bit of a page. The reason I wasn't seeing because I was looking in the wrong folder. Tired brain. I'm like, why is that not working? Let me just make sure I'm still recording. 2942, 2943. All right, so here's what I was trying to do. So let me just show that again. Get rid of that, and get rid of that, and clear this out, and come here. Go run main.go, and then dump that into index.html. And that will give me index.html, and I could open that, and I could see that, and then I could preview it, and I just created a web page. Right? So hey, sweet, totally easy, not too far. But that's really, you know, and when you compare that to like, I don't know, other server-side programming languages, it's like, that's not complicated, that's totally simplistic, that's totally makes sense. Why didn't I see that or think of that before? What's up?
Is there a web framework that works with that? Because you might give these output multi-tags.
Yeah, we're gonna, a web framework. You know, generally I'd say that the standard library has everything you need, and it gets a little bit complex when you start to do like sessions, and so you might go and get, there's another library which somebody else has written, another package which you could get which like will help you do HMAC with sessions and things like that. Yeah, totally, yeah. All right, so here's the next example. So I'm just doing this one with OS args as an argument. And so I could do go build, and that's going to build, sorry, I got to change into that folder. Change, go to, and go build. And when I do go build, it will drop that in there. And so now when I run that, is it better for you guys if I use this one? It's easier for you to see, right? And so when I run that, and that binary becomes the same as the folder name, and all those details you can kind of learn later, just the little things. And I need to provide an argument, and so I think, I don't know what argument I need to provide is like a name. And so they're, you know, just kind of building on it, and you can see how OS args works, right? But it's like, oh, that's really clean, you know, that's not complicated, right? It's really, really readable, and that's really nice. So, cool, but I'm not going to be building my web server like that. Do they have any kind of templating? Yeah, totally, they got templating. So I can create a template. So here's my template. And then here is, you know, func main, and I'm going to parse that template. Okay, bring that in. And, you know, my code needs to understand that. And then I'll get, you know, a variable, which is, you know, technical terms, a pointer to a template of type template. And then I'm going to execute my template. I'm going to execute the standard out. And I'm not going to pass in any data, right? So nil, no data is going in. And let's see what happens when I run this. So this is number 3. Go run main. Boom. Cool. We're getting somewhere. And so this is really just sort of like the drive through the countryside, which is Go, with the roof down, going really fast. So you're going to see, you know, just how that works. Well, let's continue to look at that. Here's another template, and we have some of this sort of mustache notation. So just like with mustache or whatever, those other frameworks, right? You want to do some insertions, you use that. They use pipelining. They use pipelining for, you know, passing in data. So like if I'm looping over range, that first thing would be like the range, and then if you'll see that in a second. I'm getting ahead of myself. And then here again, I parse my template. I get my pointer to a template, and then I'm going to put this as standard out, and this time I'm passing in data. And I have an expression here, 5 times 5, right? So I'm going to pass that in, and let's watch that. Boom, good. I went into the wrong one. 25. And so that's where, so in software engineering, pipeline consists of a chain of processing elements, processes, threads, coroutines, functions, arranged so that the output of each element is the input of the next. So we're gonna see that in action. And then one other thing I forgot to point out is you're seeing parse files right here and execute. There's also parse glob, or there's also parse, right? And here we have, there's parse files and parse glob, and then there's execute, and there's execute template. And so you can specify which template. You're going to see what those differences are here in a second. But
Excuse me.
yeah,
So, the title of this is Building Scalable Things. We were
Sure.
talking about how Go is, designed to exploit
Sure.
multiple cores and everything. Can you, I know you're going through this rudimentary
Yeah.
examples, but can you tell me, so what about this would be exploited to the cores? What about it
yeah.
leading to the scalability?
Well, yeah. So when we get into a situation where we need to have higher performance, we could easily use concurrency, and we could also do parallelism really well. And so concurrency is not parallelism. Concurrency is like multitasking. So I'm doing concurrency. I think I have a slide on this later, but maybe it's in this deck right at this end. No, I don't. Maybe it's here. Yeah. So here's concurrency. All right, I have multiple tasks, but they're all taking turns on the same CPU. All right, so I'm running multiple. It's kind of like me talking and trying to drink. I could do talking and drinking at the same time. I could say a little, I could take a drink, I could say a little, I could talk, drink, take a drink. I can't do that in parallel. I can't talk and take a drink at the same time, right? So parallel is all those things running at the exact same time. So if you have multiple cores, I have 8 cores on my computer. Each core, just in a simplistic way, has one thread running on it. And if I want to run my software instead on all 8 cores, I can do that in Go. All right, so I can really take advantage of all the hardware. And then they have all of the things to prevent race conditions, obviously, like mutexes, atomicity, channels to synchronize and to pass data and information from one to another. And so that's really, it's a really deep question. It's a really good question, like why is Go performant? Why is it so much faster? And ultimately, you just have to look at the benchmarks and the measurements that people have put together. It's like, why is a Lamborghini so much faster than my old 1982 Corolla, right? There's a lot of things under the hood which makes it faster. And that's one of the things about the language. As you learn more about it, you'll hear about mechanical sympathy and how they built this language to really align with how hardware works. And so, hardware, one of the things is happening with the CPU. It does all of its fetching, it prefetches, and it gets contiguous blocks of RAM and brings that into cache and, all that stuff. And so, the data structures are all arranged where if you use them appropriately, if you write idiomatic Go code, you are using them appropriately. That then when you bring things in, you're bringing in contiguous chunks of memory, right? And that helps speed it up. So there's just a lot of stuff that makes it performant. But ultimately, that's like a question that's answered when you've been working with the language for a year and you're like, oh, look at that. That's awesome, making it fast. Yeah. Here's one more look at concurrency versus parallelism. That's another good way to sort of visualize it.
Do you explicitly manage assigning bits of code to the different cores?
No, that is taken all for you. So when you launch different Go routines, I call them Go routines, and then you say, I'm going to launch this Go routine, and then it just automatically does all that stuff. And you just have to make sure that you're locking, you're preventing race conditions. And, huh? Oh yeah, thank you. I'm not so good with that. So here's the next example where we're going to loop over some data, and this kind of shows you the pipelining thing. And over here, I'm passing in a slice of ints. We don't really, arrays exist in the language, but arrays are an underlying data structure, and a slice is built on top of an array. A slice is your list data structure. We have slices, which are our lists. We have maps, which are dictionary key value things. And then we also, I like this guy, he's like, you're doing good. That's what I'm projecting on you, sitting there smiling, like, yeah, this is cool stuff. And so we have our arrays, we have our slices, right? And those are our lists. And then we also have maps, and then we have structures where we collect, fields, and we'll see some of that in a second. But here I'm passing in a slice of ints, so it's got, 1, 2, 3, 4, 5, those different ints in there. And then I'm going to loop over that with range. And then each, the first time here, that's my slice of ints, right? Okay, cool. And now I'm looping over it. This pipeline, right, is the next current piece of data. The output of this becomes the input of that. That's a pipeline, right? And so this is, my slice of ints. And then the output of that becomes the input of that, and that's what the dot's referring to. But when you first look at that, if you aren't familiar with that or have had that explained, or when you look at the docs and you're like, godoc.org and text template. So there's godoc.org text template, and when you start reading pipeline, you're like, what are they talking about? You haven't been exposed to that. And then text template, is kind of like where templating starts, and then HTML templates are built on top of it. And I'm looking at the docs at godoc.org, which is a website some dude built. But there's also Golang, like if I skip Golang text template, I'm going to get package text template at golang.org. So there's golang.org, which is the official website, and then there's godoc.org, which some dude built. I like godoc.org because not only at golang.org, I only get the documentation for the standard library. At godoc.org, I get the documentation for the standard library, and I get the documentation for, any other package that anybody else has out there, right? So it's like, oh, I need a UUID, and I can find a UUID that somebody else wrote, get that code, just go get it, pull it down, and start using it. And these are sorted in order of goodness. I think one of the ways they determine goodness is just looking at GitHub and running something that sees how much is that thing being used, and then that goes up in the ranks. So pretty cool. So that's looping. Let's see that run. And I'm an example 05. 1, 2, 3, 4, 5. So we're like, really quickly getting really close to doing some really cool stuff. And we're only at like example 5. And then here we have passing in an empty, a nil slice, right? And so here I run that. And no items, because I had some conditional logic here. I put in an else. Cool. And my editor, I haven't completely got my editor wired to get rid of these little syntax errors. So when I'm in my templates, it's a little bit annoying, but I just haven't taken the time to iron that one out. So here's another chunk of code. And again, a template, I'm passing in .name.age. All right, that's starting to look good. And I have a struct, so we're seeing the struct data type. The struct can just be a collection of fields. It's a composite data type, right? And I just bring in other data types. And so I'm putting a name. It's a string type, and an age, which is an int. And then I don't create an instance down here. This is not, you don't use the same terminology. So in Go, it's all about types. I have created my own user-defined type. The underlying type is a struct, but this is now a type in the language, and it's statically typed. So I couldn't just on the fly, change something, because here I'm creating a variable p1, and I'm giving it this value, and it's of this type, right? So I created my own type, and I'm using that type. And so it's a little bit different. So we don't talk about instances in Golang. You will see that a little bit, right? It's a little bit hard not to say that sometimes. But the terminology you'd use is, hey, I created a variable p1, and I gave it these values, and it's of this type, right, is how you would talk about that. And so, I created a variable p1 of type person, and I gave it some values, initialized it, and I parsed my template. Cool, I get my template, and I'm going to execute my template. I'm going to pass in that data, and once I pass in that data, I now have access to that data. And this is how, dot field notation, I'm accessing that data, because that data piece is my entire struct, and I want the field name from it. I want the field age from it. And so when we run that, I'm in 07, pow, James Bond 23. And so we're just going to take a little bit of a step away for one slide from doing web stuff and look at how we do methods, which is kind of like, oh, you know, my object-oriented thing. And so here I have a type person, the underlying type is struct, and then I have a type 00, the underlying person is struct, and type 00 has an embedded type person. Cool, very clean, very easy to read, no extra extraneous bullcrap words thrown in there, right? And then it has one more field, license to kill, true or false, right? So pretty straightforward. So I create a variable p1 of type 00, and I initialize it to these values, right? And so here I have, and this is called a struct literal, right? And that was a struct literal that we saw before, but here I have my struct literal. And for person, the person field, and this is the one thing which is a little bit not totally intuitive, is that I just have to use the same name that was right there. So for this person thing, and I'm not doing like, you know, person, which has slightly, you could do it, but it has slightly different ramifications. But this is the idiomatic way to do it. And idiomatic sounded weird to me at first, and then I realized, oh, you know, we have idioms in speech, right? We have certain idioms that we use, and different cultures have different idioms. And if I was to say to you, hey, the waves are big, I'm going to go get my gun, you would be kind of like, what are you talking about? Unless you're a surfer. And if you knew those idioms, you'd be like, oh, he's going to get his big surfboard, right? That's what we call a gun in surfing. And so every culture has idioms which they use to speak. And so when I say this is the idiomatic way to do Go code, I'm talking about these are the idioms, the patterns of speech we use in the Go language. And so that was just like, okay, I got to think about things in that way. It's almost like poets wrote this language when you look at it, and they were very precise in their choice of words, right? Like almost like, I don't know, haikus or something. Like every word has meaning, you know? And it's not sloppy. So here's, person, and that's, struct literal, and then here's my outer struct literal. So this is the inner type, and this is the outer type. And there's inner type promotion, and so everything that is in here, this now, quote-unquote, inherits. It's promoted. We don't say inherits, we say it's promoted. The inner type is promoted to the outer type. And so here we've got, that, and we parse the files, and we pass in that chunk of data. And here's my template. I'm going to access that data, name, age, if license to kill, so testing the bool, then license to kill. Otherwise, license to ill. That's it, man. You don't get the K, it's license to ill. Yeah.
Is this the same James Bond because he was true? Yeah.
Same what?
James Bond that I know has the license to
Well, he's not 23 anymore. Either.
Oh, did I not put like true on license to kill? I put false. So we'll see it both ways. Thank you.
He didn't have the license when he was 23.
So there we have license to ill. This was just me testing it last night, because I just want to make sure all my code totally works, because it totally sucks when you're in a presentation, both for the audience and the presenter, when you're like, oh, dude, I totally don't know why that's working. Hold on, give me 30 seconds. Right? Quickly destroys confidence. So let's change that to true. And let's try it again. Bam. Yeah.
Does int have a specific number of bits or is it variable?
Yeah, it's a great question. And does int have a specific number of bits, or is it variable from machine to machine? So if we look at Golang spec, and really, I've gotten to the point where it's like, let me see how spec talks about it, and then there's one other document which I mentioned, and it's effective Go, and let me see how effective Go talks about this. And these are both at golang.org, so these are like the official, party line, right? And so I like the way Golang the spec talks about the numeric types. And so here are all of our types, and you can see the types. All right, and method sets. Whoa, gotta learn about that. Boolean, numeric, string, array, slice, struct, pointer. Cool. Function, interface. Ooh, functions are types. So we can do everything with a function that we can do with a type. All that functional programming, though, generally stay away from the complex functional stuff in favor of lean, clean, readable map types, channel types. And so numeric types, when I first saw this, I was like, oh my god, are you kidding me? I got to figure out if I want to int 16 versus 32 versus 8. This is way too low level. I don't want to have to think on that level, right? But you have all of this flexibility. And then in practice, what you use is int or float64. And what the compiler does, when you compile your program, you have two Two, you have implementation, you have numeric types with implementation specific sizes. And this is what I mean, like they were very precise about their language and they didn't waste words and every word has meaning. Implementation specific sizes means depending upon your architecture for which you compile your program, if it's a 32-bit architecture, it's going to be int32 when you're using int because it has an implementation specific size. If it's a 64-bit architecture, it's going to be int64 because it has, that many, that's the word size that it has to work with. So it's going to build it with mechanical sympathy. It's going to build it to align with how that hardware it's running on works so it can use that hardware more effectively. Whoa, that's awesome. That's really well thought out. And so the other thing which I'll point out here is we have runes. And runes were like, I never read J.R.R. Tolkien or whatever that dude's name is. I know that like is a mark against me as a geek, right? But, rune is just a character. And a rune is alias for int32. Why is a rune an alias for int32? Let's see who's the geekiest. Let's hear it.
UTF-32 is a spec for Unicode.
Yep, yeah. So UTF-8 is a 4-bit coding scheme. 4 byte coding scheme. 4 times 8 is 32. And so a rune, a character, is a code point, and it's a number, and so it's int32.
Can the program determine when it's being compiled, whether the base system is 32-bit or 64-bit?
Can your program determine whether the base system is 32-bit or 64-bit when it compiles? Yeah, the compiler does that.
Well, I mean,
The compiler figures that out for you. And I think if you wanted to override it, you could. And you could also be on one machine and say, I want to compile for this other architecture, and you could compile for some other architecture and then deploy to that architecture. Yeah.
When you compile, what is the output? Is that the native code or is that the file?
So when you talk about, like, it's the binary, that's it. There's no virtual machine.
Is that the native code or do you need a runtime to run it?
You don't need a runtime to run it. It's binary. It's a straight executable. Yeah, so like if you're doing some, I don't know, Python or something, you got to have some Python thing running to run your Python stuff. You don't need anything. I could compile this and send it to somebody who has nothing with Go on their computer and they can run it.
Yeah, but there is a method on that one because you're going to do the memory management. And on this one, you need to manage your own memory management.
So that's like a really great question, and that's just, I think, just a little bit more detail and depth than, I want to kind of stay on track with this stuff, but I think that's just like a larger topic to explore, which is another way of saying I don't have a complete answer and I'd have to sit here with you for 5 minutes to talk about it, and I don't want to take that 5 minutes. Yeah, all right, cool. So let's keep going just so we can get through all this because this is the bread and butter right here. So I didn't actually show composition. Yeah, I did. I showed that, and then here's how you do methods, right? And so we have our 2 types, and then here's the whatever the syntax for function. So here you have your func. Again, the naming convention to Go is concise, evocative. There's actually, they use these words: concise, evocative, and something else. I just want to look it up. It's not worth it. And you want to keep things short and very evocative, very descriptive. So func, don't type anymore. And here's a receiver. So when you put a receiver onto a function, it becomes a method. When you put a receiver on a function, it becomes a method. So this is a receiver, and then here's where I pass in, my arguments or set my parameters. And then here's where I do my returns if I have returns. And we'll see more about that in a second. But here's how we do a method. So I just put a person receiver on there, and so now person has this method, greeting. And then I could do another method with the exact same name. And 00 now has this method greeting. And so I'm going to create 2 variables, one of type person, one of 00, and I'm going to initialize them to these values. And then I'm going to run each of those. And it will know, okay, which method is attached to which type, which method is attached to which type. And so when I run that, I'm just a regular person. It's Moneypenny. So good to see you. right? So I figured out which is which. And that is with, here we have the embedded type. And so the embedded type of person became promoted through inner type promotion to the outer type. The inner type became promoted to the outer type, right? So this method greeting here, where I'm just a regular person, was there, but because we overrode it, right, with the method for 00, that's attached to type 00, right? Here, right? Type 00, we overrode that method. So now we're going to look at cross-site scripting, and then how the HTML template package. We've been using the text template. So text template allows you to do templating, and it's just like the fundamental stuff, and then you can use HTML template. This package, this is text template, and here we have package HTML template. The only difference between these two files is I went from text template to HTML template, and I changed the output just a little bit. And so everything in HTML template is built on top of text template. So you go learn about text template, use text template, now I want to do it on the web. What's the additional stuff that HTML template's doing for me? So you go read that package and see what methods and functions are there for you, and you can start doing that. So let's see text template and how cross-site scripts, blah, 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 you know what I'm saying. Cross-site scripting is, text template is not escaped. And we'll put that out to index.html. And open that and run it. So here, nothing has escaped, and I was able, just because here in my template, I had some input, and what I input was this. So if I receive some input from somebody and I was just using, text templates, right, it's going to just put that straight on my page, and then when I run this, yow, like some other person put some JavaScript on my page, I didn't catch it, and that JavaScript ran, okay? Nothing has escaped. So we'll get rid of all these, close all, and we'll look at what happens when we use HTML templates. So again, I'm passing in, as if I got this from a user, a form submission or something, and here, same output in that template, but let's see how it escapes it. I think I typed that right. I might have had some extra there. Boop, boop, boop. And here you can see it's all escaped, right? So print it out again, kind of like they put it in, right? Because the browser interpreted all of those, whatever they're called, it's based on the word right now. Anybody know it? Entities, thank you, that's right. And, but cool, man. Cross-site scripting thwarted.
How do you start the website?
We'll see that. We're getting close to building a web server. We're going to build a web server up from scratch. We're going to start on TCP. We're going to create a TCP server and telnet into it and have that do some stuff. We're going to recreate Redis, and we'll be storing data that comes in via TCP. And that's just kind of fun, a little ROT13 server. And then we're going to build on top of the TCP server using the same technology, and we're going to do that with HTTP. And we got an hour. So I think maybe we'll take a break right when we get to the end of templating, and we can take a 5-minute break, and people can hit the restroom, and if people want to bail, that'd be a good time. So just hang in 5 more minutes, and this is, I think, right here, the last two. So here we have parse files. So before, the way we've been doing our templates is we just had parse files, and we're passing one file. But for parse files, just from the name, right, tells us that we can actually pass in many files. And this is cool about WebStorm. I like WebStorm because I can hold down Command and go over anything and click on it. And there's the standard library, the actual code that makes up Go, showing me how the people who created Go wrote the code, right? And this is a great resource to see how do I write Go, because this is like the people who are the best at it. These are people who are, and I say this with no equivocation, these are the people who are smarter than me, right? And I can see, okay, this is how you're supposed to do it. But parse files takes in, this is called a variadic argument. So it takes in an unlimited number of strings. Use the ... And here, this is pointing out an unlimited number of arguments, right? So that's passing back an unlimited number. Wait, sorry, that's passing back an unlimited. I'm confused. This is a function, and function is taking, as we run this function, it's taking an unlimited number of arguments. That's the way I say it. This is for defining a function, and I want to. This is my parameter. I want to take an unlimited number of strings. That's called a variadic parameter. And I haven't seen this in doc, but I call this a variadic argument. That's just my word. I don't know if that's the right word, right? Because here I'm passing in file names comes in, and then I'm using that again as an argument now to this function. You see this is capital, this is lowercase. Capital means that it's visible outside the package. That's how you say that. Not public-private, right? It's visible. Again, that's more precise. Public-private, I don't know. What are we talking about? Restaurants, parties, clubs, right? Like visible outside the package. Not visible outside the package, right? Only accessible inside the package. And so the capitalization, you don't have to have another word. It's just uppercase capitalization. I know what that means. That's visible outside the package. It's exported outside the package. This is not visible. So those are the words used. Talk about it. I can click on that, and I can go see what parse files does, which is right below it. And so here's a little bit more of the meat, right? So this is what's accessible to people, and then here is what's sort of running when I pass things in. So this is just like a stepping stone to that other one. All right, so I have parse files, and the main thing about this one is passing in multiple templates, and I only have template, what am I in? I must be in 12. I'm in 12, let me close that one. I have a template and then template 2, right? Those are the two I'm passing in, and now I'm going to execute, and I'm passing in struct here, and so I'm just doing a struct literal. It's an anonymous struct literal because I didn't give it a name. I didn't set it equal to a variable. I only need to use it in this one place, and so that's another convention in Go is, keep your variables as close to where you're using them, and don't let their scope get anywhere else. It's block level scope. It starts like at the package level, right? So I could have something that's available to the whole package, and then I could export it, make it visible from that package if I wanted to, and then I have pretty much like function level because that's inside blocks, and then inside functions I could have more blocks, and then the scope would only be in there. So here's an anonymous struct literal, and I'm passing in that data, and anonymous struct literal type page. And which template's going to execute, right? I parsed 2, and I'm just saying execute template, right? And so that's this first thing. We're just executing it without passing in. And then I also have execute template, where I could specify the template. So here I'm specifying this one, and here I'm specifying that one. So the essence of all drama and stories is what's going to happen, and answering that question. And so let's just see. So the first time through, it executes the first template, right, where I don't specify it. That's just the first one that sort of got parsed when I parse files. So it's the first one sort of in line. And then when I specify them, sorry, this was the first time through. And then this is specifying, and this is specifying. So first time through, and that's kind of funny. I should put the title in here, but which file is what I put in the title. The first time through was the first one. We see that page 1 is associated with template HTML, and page 2 is associated with template HTML. So just trying to make that as clear as possible. It's funny how quickly things can get muddy when you're first looking at a language if it isn't just really well. Let me just show you the simple stuff, right? All right, so that's parse files, and the last thing before we take a break is I can do a parse glob. And so parse glob is I just say, hey, everything in this directory, man. I don't want to have to list all the file names. That's totally tedious, right? So I'm going to parse everything in that directory, and the exact same thing is going to happen. It's the exact same code, but the only thing I've changed here is parse glob. And just to verify that, because the proof is in the pudding, and I like what the guy who created the Audubon Society said is like, if the book and the bird differ, believe the bird. And ultimately, it's like, how does the code run? You read books, you hear people talk about how it runs, but how's it run, man? So, what do I do here? There we go, that's it. And so the same output, but just illustrating parse glob. You guys just got the best introduction to Go that you could probably get. Like there's few places on the planet that you can get it. So I hope that's helpful to you, and that it's something you want to learn more about. I think it's great. I'd love to see the community grow. I'm investing heavily in this, and I'd love to see it become the next big thing. I think it has a lot of potential, and there's a lot of really strong things going for it to make it still a little bit of a gamble, but a very good bet. It's a very good bet. Like, okay, I'm going to get on board with this. You know, from the girl Cindy, who came to 2 trainings and the company needed her, to this really big growing interest in the language, all these trainings coming out, and a lot of companies saying everything isn't doing what we need it to do, except this language can now do it, and a lot of companies are switching to it. So let's take a 5-minute break, and we'll start back up at noon, 7-minute break. Or 11, we'll start back up at 11.
What's your next seminar going to cover?
We're just going to build forward from this, and eventually we'll get up to App Engine. So the namings were, the naming of the I'm not going to go into concurrency. We'll see just a touch of like, hey, here's concurrency at work at one point, but that's a little bit of a deeper subject than I feel I could do justice to. And it's still, me 9 months new to the language, is still a little bit of a learning edge, so I don't have that quite as nailed. So afterwards, if you want a little bit more, we can chat one-on-one about concurrency. Yay! Thank you very much.
Get an email list for the...
Oh yeah, the email list. If you want the book, I'm gonna come on up and you can enter your email and we'll get you the book.